Now we are taking up the fourth kind of chemical reaction, that is double decomposition reaction. See, it can be called as double displacement reaction as well, right? Because in displacement reaction, as I told you, it is a reaction between an element and compound in which the displacement of metals or non-metals occur. The more reactive displaced, the less reactive, whether it is a metal or a non-metal. It is applicable in both the cases. So similarly, in the double displacement reaction or a double decomposition reaction, whatever word you want, you can use it, because both means the same. That is, in double decomposition reaction is actually a reaction. See, I am writing a general equation for you. It will help you to understand the definition in a better way. See, it is a reaction between two compounds, right? It is a reaction, it is strictly a reaction between two compounds in which they mutually exchange their ions, right? Like there is a valency like this, we need the first one is always, it is an ionic bond, the first element always has a positive charge and the other one along with it has a negative charge. So what they are doing, they are just going to mutually exchange their ions. So that means both the compounds will get decomposed. So that is why the name suggests the double decomposition, and moreover they will get displaced. So as the name suggests, I told you, you can call it as the double displacement reaction as well, right? So it is a reaction between two compounds. Again, it is a reaction between two compounds in which they mutually exchange their ions. That means A will be combining with D and C will be combining with B. So likewise, we'll get the product AD plus CB. So double decomposition reaction is a reaction between two compounds which mutually exchange their ions, which mutually exchange their partners, right? But a correct appropriate term to be used is they mutually exchange their ions, right? So that means AB plus CD will form AD plus CB. Likewise, you can use any alphabet, just you have to remember that they will exchange their partners, right? Both the compounds will get decomposed and both the ions will get displaced. They will just mutually exchange their place. So this is a double decomposition reaction, right? Now the double decomposition reaction can yield into two products. That means it can be classified into two subcategories. One is precipitation reaction and the other is neutralization reaction, right? That means double decomposition reaction will, as a result, the double decomposition reaction will form either of the two changes, like either it will lead to the formation of precipitate, that is the insoluble substance, or it will lead to the formation of the neutral substance. So precipitation reaction and the neutralization reactions are both form the subcategory of the double decomposition reaction. So just let us look for an example for both of them. So first is precipitation reaction. As I told you, precipitation reaction is a reaction between two compounds in which they mutually exchange their ions because they come under double displacement or double decomposition. So the basic criteria is going to remain same, that they will the reaction will be between two compounds and they will mutually exchange their ions. But the difference lies is here that they will lead to the formation of insoluble substance, that is when they will form the product, say if I write X and Y, so out of them there can be a precipitate, that is the insoluble substance that will settle down. So for example, I am stating an example for you. So if I am taking AgNO3, that is silver nitrate, plus I am taking HCl, what they will form? See, Ag will react, I am writing the valencies for you. So see, Ag is going to combine with Cl. So what happens? We will get silver chloride, and HNO3 will react to form HNO3. So it will lead to the formation of the precipitate because out of them AgCl form the precipitate. Look how I am making this reaction more informative, just pointing the arrow down. So that means whenever there is a arrow which is pointing down is present along with the product, that means it will remain behind. It is a precipitate, it is an insoluble substance that is going to stay behind. So this is, and the color of this AgCl precipitate is white. So It is a white color precipitate. So see, you have seen that it is a reaction between two compounds, so obviously it is a criteria for the double displacement reaction. Moreover, you get to see they are just breaking, they are getting decomposed, these two compounds, and they are mutual exchanging their partners. So obviously it is going to be double displacement reaction. So it is a double displacement reaction which leads to the formation of precipitate. That is why it comes under the category of precipitation reaction. So precipitation reaction is that the reaction between two compounds which lead to the formation of insoluble substance that stays behind, that is called as precipitation reaction. So the other type, the other subcategory of double decomposition reaction is neutralization reaction. As the name suggests, it will lead to the formation of a neutral substance. As we did in previous units, that any chemical substance possess three kind of nature, whether it can be acidic, it can be basic, alkali also come in that base category, and it can be neutral. Neutral means that it is neither acidic nor basic, and we do get amphoteric ones also, right. So the neutralization reaction is that a reaction still again between two compounds. They will react, they will mutually exchange their ions, and suppose if they are forming the products X and Y, so out of them it is the one of them will be a neutral substance, right. So just making you more this reaction understand in a better way. I am taking an example. See, look, I am taking an acid, I am taking an base, right. So how they will be reacting? They will be, these compounds will be decomposing, like I am writing the valency, so it will get decomposed like this. Similarly, it is going to get decomposed like this. Well, now what is going to happen? This positive part will going to react with this negative part, and this positive will be reacting with this negative part. So what product we will be getting? We will be getting NaCl plus H2O. So this is a neutral substance. So that means is this forms a subcategory of neutralization reaction. That means a double decomposition is also occurring, and it leads to the formation of neutral substance as well. So whenever double decomposition reaction leads to the formation of the precipitate, any color, white, yellow, any colored precipitate or any insoluble substance that stays behind is called as precipitation, and if it leads to the formation of any neutral substance, it is said to be a neutralization reaction. So that explains what actually the double decomposition or double displacement reaction is. Now we will be taking up the another kind of reaction, that is the irreversible and reversible reaction. That means how the reactions can form the product and how product can form the reactant. So on that basis we have two more kinds of reaction, that is the reversible reaction and the irreversible reaction. So I am writing it for you, just look at the board carefully. So we have reversible and irreversible reaction. Now what is the difference lies between two? As the name suggests, reversible means that the reaction can be reversed. That means, see, I am writing the reactants, I am writing the general equation. A and B are just reacting and they are forming the product AB. Under the same condition, AB can also form, again it can also decompose back into the A and B. So the reaction which can be achieved from either side, for example, if I am starting with A and B, I can get AB, right, and if I am starting with AB, I can easily get AB, and this two half arrows which I have put is indicating the reversible reaction. That means the reaction can be achieved from the either side. For example, we have the Haber's process as the reversible reaction, indicating the reverse sign leads to the formation of ammonia, right. So it is a kind of reversible reaction which can be achieved from either side. And now when we are talking about irreversible reaction, so any reaction which cannot be reversed, in which the products cannot unite back to form reactant, is considered as irreversible reaction. For example, you are eating a food, right, you are just you are oxidizing the food. That means food is getting breakdown in presence of oxygen. What do you get? We get CO2, water vapor and energy. So can this unite, this CO2, water and energy can unite back to form food? No, it can't. So obviously it is an irreversible reaction. So irreversible reaction is indicated by a single arrow pointing that this is reacting and this is just giving rise to product, and these products cannot unite under the similar conditions, or even if the conditions are altered, they will not combine and they will not form the reactants back. So this is how we classify the reversible and irreversible reaction. I hope you got it, but still I will repeating the term which you will be using in attempting the questions. So reversible reaction is that which can be achieved from either side, whether you start from the reactant or you can start with the product, and the sign which is used to denote is this, half arrows pointing towards reactant and to product. Irreversible reaction is that which cannot be achieved from either side. It happens only in the one direction and we cannot reverse it, right? The products cannot unite to form reactants back. So it is a kind of irreversible reaction. Now coming back to different more types of reactions. So we have catalytic reaction, and I think you are familiar with the term catalyst, as we did in previous units as well, that catalyst is a substance. So first of all, I'll write the type. Let's see, catalytic reaction. So what do you mean by catalyst? Catalyst is a substance which just make the reaction happen, which just increase the rate of reaction without undergoing any change in itself. It is an important property that it does not bring any kind of change in itself. It is just increasing the rate. It is just making the reaction to happen, right? So any reaction which occur in the presence of catalyst comes under the category of catalytic reaction. Same example I am taking again, ammonia formation, N2 plus H2, reversible sign, NH3, you know that why it is reversible, you know all the conditions which are required. So N2 plus H2, reversible sign, it is forming NH3. You will be surprised to know that this reaction requires the higher temperature and higher pressure as well. But when if you are providing with the higher temperature and pressure, but still the reaction doesn't take place until and unless we use the iron as the catalyst. So in this reaction, iron is acting as a catalyst. It is making the reaction happen, right? So any reaction in which catalyst is involved comes under the category of catalytic reaction. So when we are using the catalyst, still with the catalyst to make the, you can say the, to increase the efficiency of catalyst, sometimes we use promoters also with it. Like in this case, to increase the efficiency of catalyst, we have a promoter, that is molybdenum oxide. So what will be the function of molybdenum oxide? This will just make the catalyst to act in an effective way. And now what does this catalyst do? This catalyst will just make N2NH2 to react in a proper manner so that the rate of reaction is increased and it leads to the formation of ammonia. So this is how we can have a catalytic reaction. So in the same way as we have the promoters, we have the catalytic inhibitors as well. That means we use the catalyst, but to restrict the activity of catalyst, we use the inhibitors as well. For example, arsenic oxide. Arsenic oxide is acting in our human body as you can say the catalytic inhibitor during the formation of certain enzymes, during you can say the activity of the enzyme in many biochemical reactions. So this is how we classify the reaction under the catalytic reaction. Now I think you are familiar with the combination reaction, decomposition, displacement, double displacement, reversible, irreversible, catalytic reaction. So we have done almost many kind of reaction, but still we are left with few more reactions that we are taking up. So as we know, there can be an energy change as well. We did in a chemical change that whenever chemical reaction occur, there occur a chemical change as well. So we will be doing the next type of reaction, we will be taking up on the basis of energy changes, that is the exothermic and the endothermic one.